Hello, Year 7s. This week you've been looking at pressure. Here we are. And the focus was to be able to calculate pressure and explain what causes it to change. We're just going to have a short little video about how to calculate pressure. I'm just going to go through some worked examples. So hopefully you've worked through these slides and you've seen that we have a pressure equation. Here, pressure is equal to force over area. This basically means that pressure is equal to the force applied over an area. So you've done your practical, you've got out your 1 centimetre squared paper, you've drawn around your foot, you've weighed yourself on the bathroom scales and adjusted it to find your actual weight, which is your mass times 10, and you've been able to calculate the pressure you exert on the floor when you stand on one leg and hopefully on both legs. So we're just going to look at some calculations. So we've just got to remember this, and this is that pressure is equal to force over area. So our first equation here is force of 500 newtons acts over an area of 10 meters squared. So what we're going to do then first, we're going to do something called bug FIFA. Get used to it. Teach the GCSE kids this, but if you start in year 7, you'll nail it by the time you get to year 10. So what we're going to do is bug FIFA. Just going to write that down then. So we're going to bug FIFA. So we're going to box what we need to find, underline the data, and then grab the data. And then we're going to write down our formula, insert the numbers, and then rearrange if we need to. So we're going to have to fine tune it, and then we're going to find our answer. So let's if we see this as an example. So let's just look at this then. We're going to box what we need to find, calculate pressure. So in this example then we're going to calculate pressure. So I'm going to box what I need to find, pressure, and I'm now going to underline everything, my data. So my data is 500 newtons, and my area is 10 meters squared. Now what I'm going to do is I'm going to grab my data. So my data is 500 newtons. Newtons tells me it's a force. I'm going to look at 10 meters squared. 10 meters squared. Well, the meters squared here, that tells me its area. So I've boxed on the video, on the PowerPoint, sorry. I've underlined what I'm finding out. Now I've grabbed my data. Now I'm going to write down my formula. So pressure, this is equal to force over area. So now I'm going to insert my numbers. Let's bigger. So pressure will equal force. Well, inserting a number there, well, that's 500 newtons. That's 500 newtons divided by the area, which is 10. Now I don't need to fine tune anything here. All I need to do is take 500 divided by 10, which will give me 50. That's 50 newtons per meter squared. That's our first example done. Now we're going to move on to the next one, which involves rearranging. Right. Just let me get rid of this annotation. Clear all diagrams. There we go. And we'll go back to mouse, and then we're in. So now what we're going to do is we are going to rearrange the formula. So this is slightly more difficult, but I think we'll manage it. So we're going to box what we need to find. So we're going to book FIFA, so box what we need to find. The student uses a glue stick with an area of 4 centimeters squared, putting a pressure of 0.5 newtons per centimeter squared on her book. Calculate the force she puts on the glue stick. So we're going to calculate the force. So now what we need to do is underline our data. There we go. And then the next thing we need to do is we need to grab our data. So oops. There we go. Second example. We've boxed, we've underlined, we're going to grab our data. So we need to say that we've got 4 centimeters squared. Well, that's got centimeters squared, so that's area. And then we have pressure of 0.5 newtons per centimeter squared. So it's 0.5 newtons per centimeters squared. So because this is newtons per centimeter squared, this is actually pressure, P. So now I need to write down my formula. I'm going to, so I've boxed, underlined, grab my data. Now I'm going to write down my formula. So pressure is equal to force over area. I need to insert my numbers. So we've got pressure, well, that's equal to 0.5. That's equal to force divided by the area, which is 4 centimeters squared. Now, I've got a problem here because I want to make force the subject. So to do this, what I'm going to do is I'm going to fine-tune my formula. So I need to rearrange it. So if I were to move this to this side to make force, to leave force on this side and make force the subject, what I'm going to do is I'm going to do the same to both sides. So I'm going to do the opposite of what's happening to both sides. So if I take 4 centimeters squared and times it by 4 centimeters squared, this side, and times this side by 4 centimeters squared here, what will happen is that will cancel with that, and it will leave 4 centimeters squared times 0.5 is equal to force. All I need to do then is put my numbers in to my calculator, and that will give us 4 times 0.5, and that is equal to 2. I've got a force of 2 newtons. So hopefully get that. If you're stuck about this idea of dividing, just think about what you do when you're doing, let's say, 4 times, let's say 4 plus 3 is equal to 7. Okay, so if I take plus 3 to the other side, I'll do the opposite. So this sign, I have to do the opposite if I want to move it to the other side of the equals. So that will leave me with 4 is equal to 7 minus 3, which is quite correct. So this is what I'm doing here. I'm moving parts of the equation to either side. And to do that, I have to do the opposite to the sign. Okay, you can see that again if we were to do, I don't know, 4 divided by 2 is equal to 2. So if we wanted to make 4 the subject, I would times both sides by 2 down here. So that would be times 2, and that would be 2 times here. And that would cancel over here, and you can see that we have 4 is equal to 2 times 2. So hopefully You can have a crack at those. I think you'll get them. Answers next week.